about that, you guys did a production cost exercise. And this production cost exercise looked at, instead of having something like corn and fertilizer like we've been used to, this one looks at the input being number of workers and the output being cakes. So we've got our labor workers that go from 1 to 15. We go up by 2s, and we increase the number of labor workers that help us produce our cakes. In doing so, our cakes increase, but you can still see the law of diminishing returns in this, because we see that our cakes increase fairly quickly, but then they start slowing up, and the more workers I use, then I'm really increasing my cakes, but not by as much. And if I kept hiring a couple more workers here, if I had 17 and 19, I'd probably see this output actually drop and decline. The reason for that is even with something like labor workers, it's easy to see with fertilizer or water overdoing things. But when I'm looking at workers, if I get too many people working at the same time, they actually are not as efficient. They are not going to produce as much as if I had fewer workers. So I still want to optimize, even when it's something like labor, I still want to optimize how many I'm using. So I'm comparing input of labor to output of cakes, and you were given some values in order to do that. So let's just go through and see if we can determine how we would compute each one of those. The first one is to find the fixed cost, which is it's a given amount, so there's not a lot that you need to do with that. The fixed costs are $200, and that's a given constant. So whenever you have fixed costs, that's always going to be given, and it's going to be a set amount of $200. My variable costs, however, are dependent on how many input units I use. In this case, how many workers I have. So we were told that those labor workers are $50 per worker in variable cost. So my total variable costs are going to be the number of workers times 50. So I'm going to take one worker times 50, and I'm going to get $50 in the first spot. The next spot, I have 3 workers times $50, and so I'm going to have 150. So our variable costs look like this. You'll notice that if I am down here at 11 workers times $50 is $550. So my total cost is simply those fixed costs plus those variable costs, and I'm going to add those together. So total cost is simply an addition of fixed and variable. So here we've got our total costs, but now we want to know what our costs are per unit. So we want to consider average costs. Average costs are just going to be taking each one of the totals and then dividing by the number of output that I'm producing. Okay, so for example, when I do average fixed costs, I'm simply going to take the total fixed cost and I'm going to divide by how much output I'm producing, because that's the formula for computing average fixed cost. So when I have the first value of one labor worker producing 8 cakes, it costs me $200 in fixed costs to produce those 8 cakes. Well, those 8 cakes are pretty expensive per cake in fixed costs. So it's $200 divided by 8 is $25. But if I come all the way down here to say this one right here where I'm producing 103 cakes, $200 in fixed costs divided by 103 cakes, all of a sudden I've spread that fixed cost over several cakes, and now it only costs me $1.94 per cake. That's a big difference. $25 versus $1.94 per cake is a big substantial difference. So you'll notice that our fixed costs just gradually decline because I spread them out. I spread them out over more and more output. My variable costs are very similar. So now what I'm going to do is I'm going to take my total variable costs and I'm going to divide that by output. So let's do the same amounts of output, but let's take our variable costs instead. So when I have only 8 cakes produced, my total variable cost was $50. So I'm going to take $50 in variable costs divided by 8 cakes that I can produce, and now my average variable cost is going to be $6.25 per cake. So it costs me that per cake to produce them to cover the variable costs. But if I produce 103 cakes, my variable costs have increased because the more I produce, the more costs I have of those variable costs. So now I'm going to take my $650 divided by 103, if we do it for 103 cakes, and we see that we now are going to have an average variable cost of $6.31. So it's not like average fixed costs. I'm not spreading it across more because as I produce more, these costs do get bigger. Remember, variable costs change with output produced. My total costs do the same. So what I can see with my average variable cost is look at what it does. It decreases, hits a minimum, and then it increases back up, okay? Average total cost is gonna have that same shape to it as well. Let's look at that real quick. So average total cost is my total cost divided by output. So now I'm gonna take all my costs, and I'm gonna divide by how many cakes I'm producing. So at the beginning when I'm producing 8 cakes, then I have a total cost of $250. If I take that $250 and divide by 8 cakes, I have $31.25 in total costs per cake that I'm producing. But if I'm producing 103 cakes, I have total costs of $850. So I'm going to take that $850 divided by 103 cakes, and I'm now going to have average total cost of $8.25. So if we think about these average total costs, those are our total costs per unit, yes, but they're also average fixed plus average variable added together. So average total, you'll notice here in this first one, 25 plus 625 is the 31.25. If I come down here, $1.94 plus 631 is the 8.25. So this average total cost is a compilation of average fixed costs plus average variable costs. Now, graphically, here's what those look like. Let's just mostly focus on average total and average variable.